Okay, we're going to start here with number 31. In our diagram, AE, line AE is perpendicular to line CG. So I'm going to put that 90-degree marking in there. That works all the way around, but I'm not going to jumble everything up. So angle ASD, so here is ASD, has a value of 118 degrees. And the measure of angle HSB, so HSB is 98 degrees. So when I look at this, I see that those two angles should add to 180 degrees. So let's figure out how much is extra. If I do 180 minus 98 minus 118, that means I have 36 extra degrees in there. So here is our 36. If I do 98 minus 36, that gets me 62 degrees for HSA. 62 plus 28 will give me the 90 degrees. And now it's just a matter of putting in our vertical angles. So 90 minus 36 will give us 54 degrees for BSC. 54, work those vertical angles, 62, 36, and 28. And now it's just a game of addition. So the measure of angle HSE is going to be 118 degrees. CSD is 28. DSE, remember trace these with your fingers if you need to, is 62. BSD is 82. FSD is going to be 98. And GSF will be 54. All right, what is the value of the last digit for 3 to the 41st power? So remember that first we need our rule to follow. So 3 to the first is 3, 3 squared, 9, 3 cubed is 27, 3 to the fourth is 81, and at that point our 3's are just going to repeat. So I'm going to take this 41 and divide it by the number of pieces that are in my repeating pattern. So 41 divided by 4, that will go in 10 times to give us 40 with a remainder of 1. So what this tells me is I'm going to go through this repeating pattern 10 times exactly, and I'm going to have one card left in my hand that ends in that digit of a 3. Same thing here with our 7's. So 7 to the first is 7, 7 squared is 49, 7 cubed is 343, 7 to the fourth is 2401, and if I do that times 7, it's just going to put me back at the beginning. So I'm going to take my 28 exponent, divide it by the number of pieces in my pattern, 4. This will go in evenly 7 times with no remainder. So what this means is that I go through my pattern perfectly and I end on the last digit possible, which is a 1. All right, we're going to complete these with always, sometimes, never. 2 lines parallel to the same line are always parallel. 2 lines parallel to the same line are always parallel. Now, this does not say that all 3 lines will be parallel to all 3 lines, just the 2. 2 lines perpendicular to the same line are sometimes parallel to each other. So if we are talking about coplanar, this will be our example. Here in there. In which case, yes, that works. But remember, we also have that non-coplanar example that is like the corner of our box. So I can have a right angle here and here, and these are not all, we don't have any parallel lines there. So this is a sometimes. It is an always if everything is coplanar. All right, a couple of factoring questions here. We want to completely factor 9x squared minus 12x plus 4. So I'm going to split this up into the big X, just like I did while we were working on them in class. 9 times 4 is 36. And I'm going to have a negative 12 at the bottom. So a negative 6 times a negative 6 will give me a positive 36 and add to give me a negative 12. So if I plug this into my box, I'm going to have 9x squared, and I'm going to split the negative 12 into negative 6x and negative 6x, and the 4 at the bottom. So if I look left, I can bring out a 3x and a 2, and if I look down, I can bring out a 3x and a 2, and now we just need to work with our signs. So we will have 3x minus 2 and 3x minus 2. Always look for a common, a GCF before we can get started, and I can see that I can bring a 2 out of each of these. So this gets me 7x squared plus 2x minus 5, and now we can work our big X. So 7 times a negative 5 is a negative 35, and the middle term, a 2, goes in the bottom. So I know this is going to be 7 and 5, and 7 minus 5 will give me a positive 2. So if I plug this into my box, I'm going to have 7x squared, and instead of having a 2x, I'm going to have 7x minus 5x, and then the minus 5 at the bottom. So I'm going to look left, and I can bring out a 7x, and I can bring out a 5, and I'm going to look up this time since I ran out of space. Let's see, I can bring out an x and a 1. So if I work on my negatives here, I need a negative 5, and I believe that is it. So I'm going to have this 2 out front, and 7x minus 5, and x plus 1. Same thing here, bring out whatever you can. So I'm going to bring out a, let's bring out a negative 2x. Let's put that out front. And I can bring out 2 of those x's. So when I divide here, the negative 2 is gone, and I'm left with nx and minus 7. Always, sometimes, never. If it's sometimes or never, be sure to know why. 2 lines parallel to the same line are parallel to each other. This is an always. 2 lines perpendicular to the same line are perpendicular to each other. We have seen this question previously on the other page. This is a sometimes because this is only true always if they are coplanar. Remember that that corner of a box is what could happen if we have something that is non-coplanar. If 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. This is an always. That's our theorem. The product of the slopes of perpendicular lines is -1. So if we look at perpendicular lines, I can have 2 over 3 and -3 over 2, which works. But remember, this is a sometimes because we can't have 0 and undefined. That doesn't work. The product of the slopes of parallel lines is 1. This will be a sometimes. You could have a parallel line of 2/3 times 2/3, and that is definitely not going to give you a product of 1. That would give you 4/9, which does not work. But if you have 1/1 times 1/1, that does work. Just one example. All lines with a slope of 0 are vertical lines. This is never true because those are undefined. Or you could flip that around and say that all lines with a slope of 0 are horizontal. Either way. If the corresponding angles are supplementary, then the lines are parallel. Well, we know that if corresponding lines are congruent, then our lines are parallel. So is there a case where they are both congruent and supplementary? And the answer to that is yes. So this is also a sometimes. And that is if we have two lines that are perpendicular. In that case, they would be supplementary and our lines would be parallel. If line M is perpendicular to line N and N is perpendicular to P, then line M is perpendicular to line P. This would be a sometimes, and it would be that corner of a box. In which case, they could all be perpendicular to each other. Two lines perpendicular to the same line are parallel. This is also a sometimes, only if coplanar. Is that true? 3D is a sometimes, but if they are coplanar, then this is always true. All right, identify each angle pair relationship and the transversal that they are on. So if I look at angle 6 and angle 4, I see that those are same side interior or consecutive interior angles, and they share transversal B. If I look at angles 9 and 4, those are corresponding, and they fall along transversal C. Angle 3 and angle 2, those are also corresponding, but they fall along line B. And for 11 and 2, these are alternate exterior angles that fall along transversal B. And our last set here, 7 and 5, those are alternate interior angles that fall along transversal C. So we didn't have any there that we had picked that fell along transversal A, but that's okay. They don't have to. All right, so we're going to write an equation in slope-intercept form for a line going through points 0, 3 and 5, 2. So what I need from this equation is our slope. So I'm going to have 2 minus a negative 3 over 5 minus 0. So my slope here will be 2 plus 3 is 5. 5 minus 0 is 5. So my slope is 1, and I can use either of these points to work it. If I look here, I notice that this is my y-intercept, which is my b value. So y is equal to my m1 x minus 3. You get the same thing if you used your slope of 1 and the point 5, 2. Write the standard form of the equation for the line containing 4, -8 and having a slope of -3. So I'm going to start out here with point slope form. Y minus -8 is equal to my slope of -3 times x minus 4. And we want standard form, so I'm going to start rearranging this. Y plus 8 is equal to -3x plus 12. And I'm going to move the x over, so 3x plus y, and subtract the 8. 12 minus 8 will give me 4. Slope-intercept and standard form equations to a line parallel to this and passing through 2, 7. So if my slope is a -4 and I want it to be parallel, then my slope for this one is also going to be a -4. So y minus 7 is equal to m times x minus 2. Y minus 7 is equal to -4x plus 8. Add the 7. Y is equal to -4x minus 1. So there is our slope-intercept form of the equation. And then to get our regular equation, we are just going to move over that 4x. So 4x plus y is equal to -1. Oh, and I goofed up there, sorry. I'm going to add the 7, so this will be a plus 15. That's my bad. There we go. That looks better. All right, write the standard form of the equation with a line perpendicular to 3x minus 4y equals 12 and passing through the point 5, 0. So what I need to know from this is my slope. I'm going to have -4y is equal to -3x plus 12. When I divide by the -4, the slope of this line is 3/4. So if I want something perpendicular, then my slope is going to be -4/3. So y minus 0 is equal to my slope, -4/3 times x minus 5. And I'm going to go ahead and multiply everything by 3. So 3y minus 0 is equal to -4 times x minus 5. And then let's distribute. So 3y is equal to -4x plus 20. And I'm just going to bring over the 4x. So 4x plus 3y is equal to 20. Tell whether our lines are parallel, perpendicular, or neither. So the slope of this is 3/1, and y equals 3 is a horizontal line that has a slope of 0. So these are neither. Let's see. I'm going to have a -y minus equals -3x plus 10 and divide by a -1. So the slope of this line is 3. And if I rearrange this one, I'm going to have y equals -3x plus 10. So here my slope is a -3. So this is also a neither. And down here, my y's are going to cancel. So I have x equals 5, which is a vertical line through the point where x equals 5. And down here, my x's are going to cancel. So I have y equals 5, which is a horizontal line. So these are perpendicular.